All right, welcome everyone to our very first lesson. Yay! Lots of excitement. Hopefully your first day was good, or if you're still in school right now, hopefully it's going well. But today for geometry, we're going to be talking about points, lines, and planes. It's the very basics of geometry. We have to get all of these down before we can expand to new, better, and greater things. So we're going to start with the basic geometry item, and that is a point. A point is just a location. It doesn't have shape, nor does it have size. We're going to go into this example box and just show an example of a point. Even though it has no shape or size, we have to show something on the sheet of paper. So we draw a little dot. But that little dot, we have to be aware of, actually has no size whatsoever. It's just a point in a plane. It's hard to imagine, but it has no size. In a figure, points are represented by a dot. That's what I just drew. And points are named by a capital letter. And what we usually do is we put the capital letter right by that point we drew. I'll call it point P. So you'll see this on a sheet of paper, and I'd say, what's the name of that point? And you'd say, hey, Mr. Pabian, that is point P. And you just call it a capital letter P. All right, we start with a point. Now, if we take 2 points and put them together and we draw a line through them, that makes a line. We're connecting 2 points to make a line. So our next thing is a line. And a line is made up of points and has no thickness or width. It just has length. I do want to point out something. It is made up of points. Well, if we look at the line we have drawing, it doesn't look like a whole bunch of points, but if we zoomed in really, really far, infinitely into that, you just see a whole bunch of points making up that line. Kind of like if you zoom in on a window, you get to like the pixel sizes. So every line consists of an infinite number of points that actually make up the line. Now, when we draw a line, we're definitely not going to draw a whole bunch of points. We're just going to draw a straight line. But we have to know it's made up of a whole bunch of points. Because, i.e., if I have a test question that says, are A and B the only points on this line here? You'd say, no. There's a ton of points on there, more than just A or B. So that's what we're going to start off with. So it's made up of a whole bunch of points, even though it looks like just a straight line. There's exactly one line through any 2 points. So anytime you draw 2 points, boom, boom, there's only one line that can go through those 2 points. So as soon as you have 2 points, you have one specific line. A line is shown with an arrowhead on either side. When we get to more advanced stuff, we might have an arrowhead on one side or no arrowheads at all. But right now, we're just talking about basic line. It has arrowheads on both sides to show it's a line. That is named by a lowercase script letter or by writing the capital letters of the 2 points on the line with a double arrow over the pair. So what that would look like is if I had this line right here, that red line you can see on your sheet, or on your sheet it'd be black and white, but on my screen it would be red. If I ask you to name that line, there's 2 ways you could go with. You could go, hey, Mr. Pabian, that is just line. That's not line. There we go. Line L. And that comes from that L there. Now, usually we'll name lines like that if it's present. A lot of times you'll see lines that don't even have that there. So a lot of times we're going to, that's a bit aggressive. Let's make that just a little bit smaller. And let's pretend that L is gone. Now we don't have an L to name it. We could either put our own L over it and say, hey, I'm referring to line L. But more often than not, we're going to name it this way. So let's bring that L back in, pretend it's there. Okay, so we can name it by just 2 points that occur on that line. And notice we have A and B on it. So we're going to call it line AB. But rather than writing line in front of it, we're just going to put a line over it. That line over it lets you know that it is, in fact, a line. That is line AB. Rather than using the words, we're just going to use a line above it. Alternatively, we could label it line BA. In a line, it doesn't matter which order we do it. When we get to more advanced stuff, we'll have to worry about order, but for a line, we don't have to. All we have to know is we no longer have to use the word line, we just put a line above it. All right, so that is our point. That is our line. Let's build up to a plane. So we started off with 1 point. That was our first example. Then we added 2 points. If we drew a line through it, we would have a line. A plane is going to extend in one more direction. A plane extends without ending and has no thickness. So it extends without ending and has no thickness. There's exactly one plane through any 3 points not on the same plane. So let's kind of picture what a plane is in our head right now. Now, when you're looking at this, just look above the computer or iPad or whatever you're looking at and look at that wall that's in the distance. That wall that you see is a rectangular square-shaped wall. Now, if you picture that wall extending forever left, forever right, forever up, forever down, you are now picturing a plane. A plane is like a flat wall that just extends forever up, forever down, forever left, forever right. Or a plane could be like a floor. So if you look down at your floor, if that floor extended in every direction forever, that is in fact a plane. And we'll talk more about that tomorrow if you can't quite picture what I'm talking about. But in essence, if you start with a point, we'll call it point A. Then we go with point B. Well, that's just going to be a line. And just for the sake of how we draw these, I'm going to move this point B up just a little bit. So if I connect these, we have a line. Now, we're not going to put arrows on this because we're actually going to construct a plane out of it. Now, I'm going to add one more point in that's not along this line, and I'm going to call it point. Let's see if I can put that right there. That'll work. We're going to call that point C. Well, if I connect this, and I'm going to kind of take some liberty here, we're going to create a plane ABC, D. I'm going to add another point on there. Now, this plane that I'm drawing goes forever in that direction, forever up, forever that direction, and forever that direction. But rather than putting arrows all over the place, we don't actually put those red things in usually. We just draw kind of a rectangular shape, and that's going to be our plane that exists. That plane is made up of an infinite number of points that basically scatter throughout here, and they scatter all the way forever this direction, forever that direction, forever that direction, so on and so forth. There's just a ton of points that are added together. Now let's talk about the plane a little bit more. A plane is represented by a 4-sided figure. That's what we got right here. And it's named by a single capital letter or points in the plane. So a single capital letter might appear kind of in the, if you look at the bottom left-hand corner, put a little M there. So we can call this plane M. Sometimes that letter is not there, so in those cases, we're going to use the letters that are around it. Or we could name it plane. Now, usually we use as many letters as they give us. We need at least 3 letters. So we could call this plane A, B, C. That would be enough. Those 3 letters would be enough. Or I could call it plane C, B, A. I could call it plane B, A, C. 3 letters is enough. If they ever give you 4, or if they give you 5 letters that really delineate which you're talking about, we usually use all of the letters. So I'm going to go ahead and call this plane A, B, C, D. And with a plane, the order really doesn't matter. We could have called this plane D, C, B, A. We could have named it, I guess, B, A, D, C. Usually we use either a counterclockwise or a clockwise motion when we're naming it. Not critical with planes, but it will be critical when we start naming other shapes. So let's just go ahead and always do either a counterclockwise or a clockwise direction. So in other words, if I was starting at B, I'd either call it plane B, C, D, A, or I'd call it B, A, D, C, going in either counterclockwise or clockwise fashion. So that is a point, which leads us to a line by adding another point. By adding one more point that's not collinear, we'll talk about what collinear means in just a second, we are going to have a plane. Next thing we're going to talk about is intersections. 2 lines can intersect and 2 planes can intersect. In fact, a line can intersect with a plane. We're going to talk about that in a little bit. But let's stick with just 2 lines intersecting. So the intersection of 2 or more geometric figures is the set of points they have in common. So when we talk about 2 lines intersecting, 2 lines are going to intersect at one point. Note those 2 lines there. They intersect at point O. So line H and line L intersect at point O. So when two lines intersect, they're going to intersect at a point. Now, two lines, we'll talk a little more about this tomorrow, but two lines can actually be overlapping, so they actually intersect forever. So in other words, if I had a line here, and now picture this blue line occupying this exact same space as that one. Although we have two lines there, we'll call them, I guess, M and N. They would have an infinite number of intersections. But that gets a little more detailed, so we're just going to focus on right now, if two lines cross in this manner like we have the intersecting, they're going to intersect at a point. When two planes intersect, they're going to intersect at a line. So notice plane N and M. What they have in common is this YX. Now remember, although we don't draw it, planes go forever in every direction. So in fact, it's going to overlap at that entire line. So it won't just be this little short segment, it's going to be the entire line YX forever. So the way we might denote that, we might say plane N and plane M intersect at line, notice an entire line, YX. Let's call it YX. Or we could have written that as just going, what we're going to do in the future is we're just going to call it YX and we'll draw a line above it. But I want to really emphasize that it's a line and this one is a point. All right, so that is our intersection of a line and a plane. Now we'll go into that term I've been using a little bit freely without even discussing it, but now we'll go into it, and that is collinear. Collinear are points on the same line. Now, points on the same line might not look like they're on the same line until you draw it. So my example would be, if I'm just going to draw 3 points over here. I'm going to draw A, I'm going to draw B, and I'm going to draw C. Note, there's no actual line going through those, but they are considered collinear. They're collinear because if I wanted to, I could draw a straight line through all 3 of them. So if you can draw a line through all 3 of them, it is automatically collinear. The line does not have to exist. It's just if you can draw a line through them, they are collinear. Non-collinear points, obviously they're not going to be on the same line. So let's do point A and B. We got A, we got B. Now let's put C way up there. Well, I can't picture one straight line that would go through all of those points. If I try drawing lines through A, that doesn't go through B. If I draw through A and B, that doesn't go through C. So because I can't draw one straight line through them, it is non-collinear. Or you can simply say it's not collinear. So collinear, once again, if you can draw a line through it, it's collinear. If you can't, it's non-collinear. Now let's talk about coplanar and non-coplanar. Just like lines, collinear meant it could be on one line. Coplanar means you can put points in the same plane. Now this can be a little confusing when you're picturing stuff, so I kind of drew a box off to the side here. And we have a whole bunch of planes. Now remember, a plane is kind of any rectangular shape, but we should remember that it goes in every direction, kind of like that. All right, so what I'm going to do is I'm going to name some points that are coplanar, and then we'll talk about what points, or why they actually are coplanar. So my first example is, I'm going to do the points Q, R, S, P. So if we look at Q, R, S, P, note that they're on one plane. I can draw a rectangle and it encompasses all 4 points. Another example might be R, Y, Z, S. Let's look at R, Y, Z, and S. R, Y, Z, and S Can I connect those all on one flat surface? Yes, I can. They kind of make that wall right there. Now I'm going to do a slightly harder example, and that's going to be Q, R, Z, W. Are those coplanar? Well, if I highlight those points, we have Q, R, Z, W. Well, it's not quite the walls that we were talking about before. So at first glance, it might look like they aren't coplanar. But just like collinear, coplanar is always coplanar if you can draw a flat surface through all of those. So let's picture this drawing. See how it's this flat surface is just kind of angled? Because I can connect all four of those points and it makes that flat wall, they are in fact coplanar. Those are my three big examples. There's a ton more examples on this drawing, so I'm just going to go ahead and put dot, dot, dot. Might be a good idea to see if you can pick your own and ask me if they are coplanar or not coplanar. The next thing we're talking about is not coplanar. Obviously, that can't be on the same plane. So my example for this one would be Q, R, Y, Z. That's kind of a Z. That's a better Z. Let's highlight those points. So Q, R, Y, Z. Now let's focus on Q, R, Y. Q, R, Y are in fact coplanar. That's me drawing kind of a triangle, but you can see it's a flat triangle, so we could have extended it like that. Those are all 3 points are coplanar. However, as soon as we throw Z in the mix, I can't draw that box anymore. We kind of are stuck with this weird shape that is no longer one flat shape. So those are in fact non-coplanar, and that's because we have 3 that are on a plane, and the 4th one is not on that plane. In fact, that's my little trick to you. If I ever ask you for 4 points that are not coplanar, what I always stress to find a non-coplanar point is pick 3 that are on one given plane and a 4th one that is no longer on that specific plane. So an example of that might be, I'm going to pick R, S, Z. Now, those make this plane. So let's go ahead and point that out. So I was talking about R, S, Z. Now my 4th point just can't be on that one plane. So you can pick any one of these points over here. Let's go ahead and pick Q. So R, S, Z, Q are not coplanar because R, S, Z are coplanar and Q is not on that same plane. All right, that's coplanar, non-coplanar. Let's talk about some common phrases. Actually, in fact, just go through and read all of these and we'll discuss them further tomorrow, which would be that Tuesday. Continue on. What I want you to finish up, I want you to go through example 1. Example 1 is you're just looking at that picture and you're answering all those questions true or false. I also, for tomorrow, want you to finish example 2. Once again, we're just looking at that picture and we are looking at answering these questions. Like 9 says, are there any points in CG besides C and G? If you're not sure what that answer is, rewind this video to the beginning when I talk about lines, because you'll have the answer right there on that one. That is all I'm expecting you have done tomorrow. Don't worry about this homework section. That will actually be due on Wednesday. So we'll have tomorrow to talk a little bit more, and you'll have a bunch of time to work on that homework. Hopefully you got to this video okay, and everything's going well for you so far. I'll talk to you tomorrow.